Okay, so we'll start the class. Everyone turn on the camera, please. Everyone turn on the camera, please. Quickly. Jahan, your network is not good. Today you can take rest for turning on your camera. Okay. So we were doing acceleration and velocity, initial velocity, final velocity. So I want to ask from yesterday, Johan, I also didn't, no, Johan attend the class yesterday. Yesterday, Johan attend the class, no? Yeah, Johan attend the class. Joshua and Johan, we did some questions yesterday. So did you saw that video?
I couldn't see the video yesterday because I was out of station.
Okay. So today, please go and check if you have any problem during acceleration because we did acceleration, no? The initial velocity, like final velocity minus initial velocity upon time. Johan, just give me a thumbs up if you saw the video yesterday. You can unmute your mic if it's okay. Yes. Okay. So do you have any problem?
See the
Okay. Okay, no problem, no problem. I can understand, but please go and check out that thing, and please try to improve your network by tomorrow if it is okay. Okay, so that we can have that thing, and like we will have science test also on Friday. Friday we will have science test of chapter life process. Hannah, are you okay for that?
I'll try, sir, but on Thursday you're busy and on Wednesday also you're busy, so I'll try to do it before.
Or we can do on Monday, next Monday.
Monday,
Will it be okay?
not sure I'll be
It's okay. I'll send the test, and if you have time, then you have to give it to me. If you can join in class, you can join in class. Yes, Jehovan, please. Jehovan, please. You have doubt?
Sir, we won't be available on Monday, Tuesday, and Wednesday.
Okay. So we'll decide as Friday. Okay, and if Hannah will not join or if she has some trouble, so she can give at home and send it to me. Okay. Are you getting any disturbance from my side? No. So we did acceleration. Now today we'll learn about acceleration more. So acceleration is of two types. First is acceleration itself, and the second is so we can write it like this, like positive acceleration and negative acceleration. Negative acceleration. So what do you mean by positive acceleration? Positive acceleration is the acceleration when the value of acceleration is in plus. For example, AS plus 5 meter per second square. So if it is written like this, it means as positive acceleration. Now, what's the role of positive acceleration? It increases the speed. It increases the speed. Like if the speed was 5 meter per second, so it will increase to 20 meter per second because of positive acceleration. So when we are getting value as positive, it means that always the speed will increase. Guys, did you understand? Yes or no? Please tell me. And what do you mean by negative acceleration? The negative acceleration, the value of acceleration will be in minus. Will be in minus. Now, what's the role of this? It always increases or decreases? Decreases the speed. Yes, it always decreases the speed. So, if it is written like this, that a bike was moving with this speed and it applies the brake and it stops. So when you are applying the brakes and it stops, it's called as negative acceleration. You are putting acceleration but against the speed. Yes or no? So the speed, if the speed is 10 meter per second, so it will stop to 5 meter per second, or it will 2 meter per second because of negative acceleration. This is also called as retardation. Means the acceleration against the speed is called as retardation. Understood, guys? Yes or no? Yeah. Write it down. Now today we'll learn about the the chapter which we are doing. Like we take three classes of the chapter, which was previous chapter, but it was linked. I can't do anything. Sorry for that. Johan and Johan, are you there, beta?
Oh, yes, sir.
Okay, you understood this thing, beta? Any
Yes, sir.
problem?
No, sir.
Okay, so please submit me test before 6. Okay,
Yes, sir.
perfect. Very good boy. Done? Shall I read this, guys? Joshua saying 1 minute. Okay, Johan, your network today is not working good. So what you said, I don't know, but you can message me if you want to say something. Okay, done? Yeah, we are waiting for Joshua. Done, Joshua? Very good. Now we learn about balance force and unbalanced force. So what is balance force? We learned that there are 4 gymmers who are just pushing the car, but they are not able to move the car. Because 2 are pushing from this side and 2 are pushing from this side, and because of that, when they are pushing it, the car is not moving. So that is called as balance force. So the force which is applied, okay, in opposite direction so that they can cancel out each other and having no movement in the body is called as balance force. We learned about that. And unbalanced force is like, for example, if you can see that, can you see this chair? Okay, if I am pushing it, so now it's moving. So this is called as unbalanced force because the unbalanced force always gives movement. Always gives movement. Understood, guys? Yes or no? Now we'll learn about Newton's first law of motion. Okay. So first we'll learn Newton's first law, then we'll learn about it. Just give me a second. Okay, read this. Quickly read this. Anybody? Joshua, read this.
Should I read out loud, sir?
Yes, yes.
Newton's first law of motion. Every body continues in its state of rest or of uniform motion in a straight line unless it is compelled by some unbalanced force to change that state.
Okay. So we'll take one example. Okay, we'll take one example. Can you see that chair? Can you see that chair? Now this is at the state of motion. If it is at the state of motion, no, it is in the state of rest because it's resting. Yes or no? Now, if it is at rest, so until unless I push that chair, it won't move. Na? So if I am putting force on it, that unbalanced force on it, so it's moving now. Yes, it's moving because I am putting unbalanced force on it. Understood? So that's the first law of motion. And unless, repeat after me with mute mic, until and unless an unbalanced force is applied on an object, repeat, an unbalanced force applied on an object, the object won't move. The object won't move. Means even like if you will put balance force, the object won't move because we learned about the balance force. Now, what is the unbalanced force there? That until and unless what? Until and unless what? An unbalanced force is applied on it. Understood, guys? No, you didn't understand it. Yeah. So we can take one example for that. There is a box. Okay. Now, if I am putting force on it, then it will move. Okay. So this is the first law of motion. First law of motion. Does you understand? No. Okay. Now, if this is the one at the state of rest. Okay. But what this mean? Or a uniform motion in a straight line. What does this mean? We learned that until and unless an unbalanced force is applied on a stationary object, it won't move. This we learned. Yes. But in a uniform motion, what does this mean? So as I told you, there are two types of accelerations are there, negative acceleration and the positive acceleration. The negative acceleration will reduce the speed. Yes. So for example, if this is a pen, pen, like for example, if this is a pen, can you see that? Okay. Now, if I will just leave it, so it is in at motion. Yes, it is at motion. Yes or no? So for stopping that, I need to put an unbalanced force. For example, this is moving like this continuously. So for stopping that, I have to put my finger on it so that it will stop like this. Like this. Yes or no? So I am putting an unbalanced force in the uniform motion to stop also. So first law of motion also says that if the object is at moving at the uniform speed, like for example, if it is moving with a 20 kilometer per hour speed, for stopping that also I have to put an unbalanced force. For moving, I have to put an unbalanced force, and for stopping also I have to put unbalanced force. This is the first law of motion. Understood? No. Yes or no? Quickly write it down. Quickly write it down. We were in BBS, so I did that inertia and the mass one activity from there. So first of all, we'll learn about inertia. Okay. So we can understand it like this. Did you saw that video in which the waiter just pull out the clothes which is on the table, and when he pull out the clothes, the things which is on the table was remain on the table only. Did you saw that? Yes or no? Hmm? Okay. So it's basically we can understand it like this. I'll show you one video, then you will understand. Just give me a second. It's downloading. Just give me a second. Mobile, I'll show you with in mobile. Okay. Can you see this video? Okay, I will show you this video and then we will learn. Okay.
Let me go. ऐसे आप बोलोगे तभी मैं गिराऊंगा। क्या मैथ्यू है? मैथ्यू कह रहा है कि let me go. Let me go. जोर से.
Can you see this, guys? Okay, I'll rewind it little bit before. See, now you can see that there is an egg. Okay, so and there's a plate. So when I will just take out this plate, okay, with forcefully, then you will see that if it should be like this. Now that egg should will also go in this direction. Yes. Okay. But what happens in this case? That egg is not going in this direction, but the egg fall in downward direction in the bottom. Understood what I'm trying to say, guys? No. When I'm pulling this plate, the egg should go in the left direction with the plate. But it's not going, but rather it's falling in the water only. Okay, we'll start that thing again.
जोर से.
Did you saw? Did you saw this thing? See, even when I just take out that plate, the egg is not going with plate. Okay, the egg is not going with plate. It's not going with the plate, but it's falling into the that jar. Why it's so? So now we will learn about the inertia. So what is inertia? Inertia is the property of a a of a what? Property of a object to resist the motion. Can you see that? Resist the motion. Now what happened? Okay, now you can understand it like this. See my picture, okay, video picture. For example, this is a chair, okay, this is a chair. Now I am putting force on chair, but still it's not moving. Yes, I am putting force on this chair, but still it's not moving. Yes or no? But when I will put more force, then only it will move. Yes, now it's moving. In the same way, this is stable. If I will put force on it, it's not moving. See, I'm putting my thumb, everything is not moving. Because it has more mass, then it has more inertia. Yes or no? Yes or no? So inertia is the property of an object to resist the motion. Whatever unbalanced force which I am applying it, so until and unless that part will be at motion, that will be at rest, till like if I'm putting force which is more than its inertia, it will move. Now in this case we will understand. See, when I remove this plate, I did a motion to this plate, but the egg remained in the state of inertia. Okay, in the rest, inertia of rest. We say inertia of rest. Okay, we'll learn more. See, now the egg is at rest. Yes, you can see that the egg is at rest. This egg is at rest with the plate. Okay, okay, the egg is at rest with the plate. Now, in the next case, if I will do yeah. Uh-huh. Yeah, this is perfect. See, now in this case, when I remove the plate in this direction, I put a motion on the plate. On the plate. But the egg wants to remain at the rest. This is inertia of the egg to remain in the stationary position. Like whatever position he has to maintain it because of the inertia he has it. Understood, guys? Joshua, Johan, Jehoan, the egg wants to remain in that inertia part. So that's why the egg is not moving with the plate because of his mass. The egg has more mass than this cup and this plate now. So that because of his mass, why am I not able to push this table, push or pull this table? Because the table has more mass than this chair. So because of the more mass, it has more inertia. Yes or no? Yes or no? So in the same way, in this video, you can see that the cup is going in that motion of the plate. Like cup is going in left direction. Yes or no? But the egg is remaining at the same position because his egg has more mass than cup and plate. Okay, that's why the egg is going into the water bottle again. Understood, guys? No. Did you understand, guys? Johan, Jehoan? Johan, did you understand, guys?
Yes, sir.
No.
Yes, sir.
Okay, so this is called as inertia. So if more mass is there, then inertia will be more. Okay, if more mass is there, then it will be more inertia. More mass means more inertia. Okay, guys? Yes or no? Write it down. For doing this activity, I broke 4 eggs. I mean, it was VBS, no? So one day before VBS, I was preparing for this activity, and I used raw egg. Like this is boiled egg. That's why it's not breaking. I mean, I have that confident that it won't break and it won't like do the problem mess there. So before that, I was using raw egg and I was doing it, but it is the inertia of motion, inertia of rest that's putting that egg in the same direction, but it's not coming in the jar. So it's falling here and there, here and there. And I broke 4 eggs there. Then I was in on my bed and I thought when I boiled it, then it won't break. No, even if it will break, then it won't like the yolk will won't come out from it. So that's why I boiled it and then I show it on the VBS. It's too expensive activity, like 40 rupees. I think so. No problem. Done? Yes or no? Okay.
जब मैथ्यू
And you can see that after doing this activity, I have a smile because the activity got good. Otherwise, 4 eggs before night, I had 3 eggs waste on this. So I thought that if it is fall outside the jar, then what will happen? It was like that. So thank you, God, for helping me. Okay, so this is what inertia, and I want you to read. Okay, now this is inertia of rest. The object is at rest, and when the motion comes, it remains at rest because of the inertia of rest. It happens with us also, like we are sitting. Okay, we are sitting, and the car starts. Okay, car starts to move in forward direction, so our body moves in backward direction. Okay, why? Because our body, the legs is at with the car. Now, when the car starts, okay, the body is with the leg part is in the attachment with the car, so the upper body part is at rest. Right now, I'm sitting like this. So when the car moves, our body, which is at rest, wants to be in rest, wants to be at rest. So that's why it's not going with the car, it's going in the backward direction. So it remains at rest, the car is moving in from forward direction and we feel at backward direction. Or we can understand it like this. This is called as inertia of rest. What is called? Inertia of rest. The object which is at rest wants to be at rest. Okay. Now the second part, inertia of motion. Motion means like the car is moving, car is moving, car is moving. Now what happens? The car is moving, but our body wants to be at motion. But the sudden brakes, we will go in forward direction because our upper body has motion only. But when sudden brakes is applied, we are also moving in forward direction. This is called as inertia of motion. Understood, guys? No. Huh? Now the third part is inertia of direction. Direction means like if Papa is taking woo, so we are going woo like this. If Papa is going this woo, then we are going like this. So in opposite direction of the direction. Like if the car is moving from this to this, then we will go to this direction. Okay. Why so? Because of our body wants to be at remaining inertia of direction. Like whatever direction is following, we want to be remain in that. But if the direction change, then our body will resist. Like upper body will resist that. Understood, guys? No. Yes or no? So there are 3 types of inertias are there. I want you to go and read these 3 types of inertia. Inertia of like it is not detailed given, but I hope you will go and you will read them. Okay, understood, guys? Johan, understood? So I hope you enjoy. Okay, very good. So I hope you enjoyed the class. Till then, bye. Have a nice day. Signing off.